Welcome to your live session, your weekly recorded, I should say, recorded session of the week. It is the week of October 27th, and we are also in the week 11 of the semester. Hard to believe we are cruising through. It's hard to believe we are in week 11 already. So when you go to do your assignments this week, please do make sure that you are working in the folders that are labeled week 11. I do have some warm-up questions for you. We are starting a brand new unit this week. So we will be starting unit 3 this week. And the concepts that we are going to start with are a little bit of review. We're going to be looking at how we can determine if lines are parallel or perpendicular. So our warm-up question, our warm-up question deals with parallel lines, and you're going to be learning about this in Unit 3, Session 1, I believe. So this probably is going to be a review from algebra. If it was last year that we took algebra, so that is why we are starting this with a warm-up. So how can we tell if two lines are parallel? How can we tell if two lines are parallel? Well, we need to figure out what the slope is of our two lines. So we've got two equations here. We've got this equation and this equation. And neither one of these equations, well, actually, our first one is in slope-intercept form. And we want to get both of our equations into slope-intercept form so that we can determine what the slope of each line is and compare those to see if they are parallel or not. So let's grab a different color here. Slope-intersect form is y equals mx plus b. That's what we want. That slope-intercept form. And that allows us to quickly determine what the slope is. Remember, the slope is going to be the m, or the term that is being multiplied by x. So if we look back over at our two equations, that first equation is actually already written in slope-intercept form. I'm just going to rewrite it with the y in the front so that we can see that more easily. 3x plus 8. So what would be the slope of this line? Remember, it's the m term, or it's the number that's being multiplied by x. So here we've got 3 being multiplied by x, so our slope is going to be 3. Now our second equation, unfortunately, is not in y equals mx plus b form. So we need to solve for y in the second equation. So let's just go ahead and solve for y so that we can get it into y equals mx plus b form. So we want to get y all alone, so I'm going to start with adding 6x to both sides. And then I'm left with 2y equals 6x plus 8. We can't combine those. Those are not like terms. And then to get y all alone, we're going to divide by 2, and then we're going to divide this whole right side by 2 as well. And we're going to get y equals, we want to divide each term divided by 2. So we want to do each term. We're going to take 6x divided by 2, which is going to give us 3x. 8 divided by 2 is 4. So now we've got this equation in slope-intercept form as well. So up here, our slope was 3 because it was being multiplied by x. What is the slope in our new equation that we just solved for x? Or solved for y to get in slope-intercept form? Remember, the slope is always the number being multiplied by x, so the slope would be 3. So our slope would be equal to 3. And what do we know about the slope of parallel lines? What do we know about the slope of parallel lines? We learned this last year in algebra. Parallel lines are going to have the same slope. So parallel lines, we can say parallel lines, have same slope. So here our slopes were the same. They're both 3. So these two lines are in fact, yes, they are parallel. Because each equation has the same slope. So I'm going to go on to the next slide. If you need more time with this slide, go ahead and click pause. Reminders, make sure that you are checking your grades frequently, just so that you're aware of what is your overall grade in the class, and then get more specific. Check what your overall grade is, but then look at how you're doing on each individual assignments. Make sure you're looking for missing assignments, look for assignments you started but didn't finish, and get those turned in. So what are we learning about this week? We're going to review lines and slope in Unit 3, Session 1. We're going to review systems of equations, and then go on to something that's going to be new for you, and that's learning about polygons. So you're going to see what we're really focusing on in Unit 3. Is going to be quadrilaterals. So we're going to be working with more of quadrilaterals, four-sided figures in Unit 3. So the beginning of this week will be more review, and then we'll get into some new stuff for you. Alrighty, so we already solved this question with the warm-up problem with parallel lines. So we've learned that parallel lines will have the same slope, and that we have to get the equations into slope-intercept form, y equals mx plus b, to determine what the slope of our equations are, the slope of our lines. That's always going to be the number multiplied by the x term. Let's do a quick review here. Unit 3, Session 1. About slopes of lines, and we're talking about slopes of parallel lines. We're going to talk about perpendicular lines here in a second. So it says, the question says, which line is parallel to the line with the equation y equals negative 2x plus 5? So the first thing we want to do is identify what is the slope of the equation that was given. So in this equation right here, what is the slope of that line? What would be the slope of that line? Well, remember, it's always going to be the term that's being multiplied by the x. So it's going to be negative 2x. So here, our slope equals negative 2. We don't say x. X is not part of the slope. It's just the number being multiplied by x. So the slope is negative 2. It's not negative 2x. So now we need to figure out which of our choices below also has a slope of negative 2. So this will be a great review of different ways to calculate slope given different types of information. So for choice F, we're given 2 points, and we have to figure out what would be the slope of a line that intersected those 2 points. A, that has a coordinates of 2, 3, and point B that has a coordinate of 1, 1. So if we are given 2 points, we have an equation that we can use to help us find the slope. So do you guys remember that equation? And this is why it's great review. Make sure you're taking awesome notes as you're watching this. Remember, you can click pause so that you can take better notes. So slope, when given 2 points, we find slope by subtracting your y terms, y1, and divide it over the subtraction of your x terms. So slope, remember, is rise over run. So to find the slope when you're given 2 points, you subtract your y coordinates, and then you divide that by subtracting your x coordinates. So here, if our points that we are given is 2, 3, and 1, 1, this would be our x1, our y1, our x2, and our y2. So to find the slope, we subtract y2 minus y1. So I'm going to subtract, let's color code that so that, this should be review. You're going to subtract your y2 minus your y1. So that's how I got that 1 minus the 3. And then we divide that by, we're going to do the same thing. We're going to take our second x coordinate and subtract it by our first x coordinate. And if we want to color code those so that you guys can see that better, we're taking our second x, subtracting by first. All right, and what do we get? 1 minus 3 is negative 2. 1 minus 2 is negative 1. Right? So 1 minus 3. Watch your negative signs, and 1 minus 2 is negative 1. So negative 2 divided by negative 1 is a positive 2. That's not the same slope. Remember, we want to find the same slope of our original equation that we were given, which was negative 2. So this one is not an option. Let's look at G. What is the slope? That's already in slope-intercept form, which is very nice for us. And what's the slope of that line? It would be negative 1/2. That is not the same of negative 2. So we're going to keep going there. Looking at option H, we need to get that in y equals mx plus b, or y slope-intercept form, so we need to solve for y. So we've got 4x plus 2y equals 10. We need to solve for y so that we can determine what the slope of this line is. So we start by subtracting 4x. We get 2y equals 10 minus 4x, divide each side by 2. Remember, when I divide each side by 2, I have to divide each term divided by 2. So I'm going to take 10 divided by 2, which is 5, and then negative 4 divided by 2, which is negative 2x. So what would be the slope of this line? So what number is being multiplied by x? Negative 2. There's a negative in front of that, so it's negative 2. Oh, look, that's the same slope of the original line, so that's going to be our answer. Our answer would be choice H. Choice H, this equation right here, because we determined that negative 2 was the slope, which is the same as the original equation slope. So parallel lines have the same slope. And to determine what the slope of a line is, we need to put it into slope-intercept form. Y equals mx plus b, and then slope will always be that number being multiplied by x. It won't include x, it's just the number multiplied by x. Good. You're also, I believe, did we leave out in Unit 1, Session 1, perpendicular? You're going to learn about perpendicular. Let's do a new. So remember, perpendicular lines are lines that intersect at 90 degrees. And the slope of perpendicular lines will be, whoops, I meant to say B, will be opposite in sign. So will be, I probably should have moved this down. Will be opposite in sign. And reciprocals of one another. So let's see some examples. What do I mean when I say opposite in sign and reciprocals? So let's say the slope of one line is 1/2. The perpendicular, the line of the slope of the perpendicular line would be opposite in sign, so it's going to be negative since the original slope was positive, and then it's going to be the reciprocal. So reciprocal just means to flip a fraction upside down. So here's another example. Let's say we had a slope of a line was negative 3/4. The slope of the perpendicular line would have a slope of positive, because you want to change the sign, and then flip it upside down, 3/4. So slope of perpendicular lines are going to be opposite in sign, and then there also will be reciprocals of one another. If you have a whole number, like let's say -4, the slope of the perpendicular line, remember, you can just flip a number. You can say any whole number is divided by 1. So when we flip that upside down, it would be 1/4. Because any whole number, like 6, you can write as 6/1. That will help you find the reciprocal. -7, you can write as -7/1. That will help you find the reciprocal, which would be 1/7. So any number can be written over 1, because that's saying 6 divided by 1, which is 6. -7/1 is the same thing as saying -7. Alrighty, systems of equations is Unit 3, Session 2. One way to solve a system of equations, remember, is when you have more than one equation. And this is, you guys did do this in algebra last year. So it's when you have more than one equation and you're trying to find an x and y value that when you plug it into both equations, it will make both equations true. So you're trying to find a value of x and a value of y that when you plug it into both equations, it will make both equations true. So one way that we can solve a system of equations is by substitution. And if you have one equation where it says y equals or x equals, that's a good indicator that you can use substitution. So if you have one equation that's set up with x equals or y equals, that's a good indication that you can use substitution. So what you're going to do, if we look at this top equation, it says y equals 2x. So it's telling me that wherever I see a y in the other equation, that I can plug 2x in for that y, because I know that y is represented with 2x. So I'm going to take my first equation and plug it into my second equation. So when I see the y, I'm now going to substitute in 2x for that y. Set it equal to 4x plus 12. So now I've got one equation and I can solve for x. So I'm going to go ahead and subtract 4x from both sides. And I get 2x minus 4x is negative 2x. So watch those positive and negative signs, equals 12. Divide each side by negative 2. And I get x equals 12 divided by negative 2 is negative 6. So let's make sure that this works. Oh, we still need to solve for y. We still need to solve for y. So looking at our original equations, I look at that top equation and it looks a lot easier to plug in. So I've got, remember, our original equation is y equals 2x. Well, now I know what x is, so I'm going to go ahead and plug in whenever I see x, I'm going to plug in negative 6. And I get y equals negative 12. Y equals negative 12. So I have a value for both x and y, and that's what you want to do, is you need to first solve for one of your equations, and then you can plug that value into either equation and solve for the other variable. All right, elimination is when you line up your systems of equations. So this is another way that we can solve a system of equations, is by elimination. And when you line up your equations, when you add your equations together, what you want to do is eliminate one of your variables so that you're only solving for one variable at a time. So looking at these equations, I can see that it's really nice to just, if I look at the y's, if I add positive y minus or subtract those two, I'm going to eliminate the y. So when you use elimination, you're always adding equations together. And you'll learn this week that sometimes you might need to multiply each term by, or each term in your equation by a number, so that when you add the two equations you can eliminate something. And you'll see more examples of that when you work through the lessons this week. In this case, it was nicely set up so that when we go and add the two equations, our y's are just going to cancel out. It's already set up really nicely for elimination. So you're always adding your equations together. So 2x plus 3x is 5x. Our y's are gone, and we set it equal to 9 plus 16, which I know is 25. Divide each side by 5. I get x equals 5. I'm not done yet. I need to solve for y. So I can choose either equation. It doesn't really matter. I'm just going to go with the top equation, and I'm going to plug in now my value for x into that top equation. So I've got 2. I know x equals 5, so instead of writing x, I'm going to write 5. Plus y equals 9, so that's 10 plus y equals 9. Subtract 10 from both sides, we get y equals negative 1. And when we plug both of those values into the bottom equation, it should work. So let's check our work to make sure that we did everything correctly. So that bottom equation says 3x, so I'm just checking this equation, that original bottom equation, when I plug in the values that I just found to make sure that it works. Minus negative 1 should equal 16. So 3 times 5 is 15. I've got a negative and a negative, so that's going to be plus 1 equals 16, and that is true. So we know we solved this properly. I'm going to go to the next slide, so go ahead and click pause so you can finish taking good notes here. The third way to solve a system of equations is by graphing, where you'll graph each line, and then wherever they intersect, that coordinate will be your answer. But in order to graph lines, we need to get them into slope-intercept form. We need to get them into y equals mx plus b. So we need to solve each equation for y. And we've already had some practice with that today, getting it slope-intercept form. So let's go ahead and take that first equation, 4x minus 6y, that's an x, equals 12. We're going to work on solving for y, so I'm going to subtract 4x from both sides. I get negative 6y equals 12 minus 4x. Divide each side by negative 6, divide each side by negative 6, and I get y equals, again, I have to do each term divided by 6. I have to do each term divided by negative 6, actually, that's a negative 6. So 12 divided by negative 6 is negative 2. And then negative 4 divided by negative 6, that is going to be a positive 4, 6x. And then we know that we can actually reduce that fraction. So that would be divide each side by 2, so we get 2/3 x. So let's go ahead and graph this line since we've got it fresh on our mind. Once we have it in y equals mx plus b form, remember the m is always going to be your slope, the number that represents m, and then that b will always be your y-intercept. That b represents the constant. So let's get some different colors going here to represent that better. So b will always be your y-intercept, and then the number being multiplied by your m, or your x, will be your slope. So the m here, our slope, is going to be 2/3, and then the y-intercept, that's our constant term, that's just going to be our negative 2. So the y-intercept tells us where it crosses the y-axis. So if it crosses at negative 2, I'm going to go ahead and put my point there at negative 2, and then the slope is 2/3. So it's going to tell me rise, go up 1, 2, and then run, go to the right 1, 2, 3, because it was a positive 2 and a positive 3. We'll do that again, up 2 and over 1, 2, 3. So once we have 3 points, we can draw our line in there, but just wanted to review, the constant term is always our b. That's always going to be our y-intercept. So this is from algebra last year. So that's why I plotted my y-intercept at negative 2. I went 1, 2 over 3, 1, 2 over 3. Go ahead and draw that line in there as best we can. And then we're going to do the same thing with our other equation. Get that plotted. I'm going to try to move this over a little bit so that I can get the other equation. Let's do that in green. We've got to solve 2x plus 2y equals 6. We need to solve for y, so we subtract 2x from both sides. We get 2y equals 6 minus 2x, divide each side by 2. So remember, we're dividing each term on the right by 2. So 6 divided by 2 is 3, and then negative 2 divided by positive 2 is negative 1. So we would have negative 1x. So I can just put in x. So our our slope-intercept would be 3, and our slope is going to be negative 1. Our slope is going to be negative 1. I just don't have that negative 1 in there. We don't have to put a 1 in there. So let's go ahead and plot that. We start at positive 3, and then we're going to go down 1 and to the right 1, down 1 to the right 1, down 1 to the right 1. There's where we're overlapping. That's where our two lines are going to intersect. Is right at that point right there. Let's go ahead and highlight that point. We'll do that in yellow. Highlight this point right here. That is where our two lines are intersecting. What are the coordinates there? The coordinates are going to be 1, 2, 3, 3, 0. So that is also the solution to our system of equations. It's going to be x equals 3 and y equals 0. X equals 3 and y equals 0. That's the solution. All right, I'm going to go to the next slide. If you need more time, go ahead and click pause. I did just want to really quickly do a little intro to polygons, which is Unit 3, Session 3. So polygon is any shape that has all closed sides. So all lines connect. It's made of all straight lines. So you can see some examples of polygons. These are all examples. They've got all straight lines and all the lines connect. There's no gapping holes. So regular polygons are going to have equal sides. So in a regular polygon, they're going to have equal sides and equal angles. All angles will be equal and all sides will be equal. Where irregular polygons, you can see the side lengths don't have to be equal. The side lengths aren't equal for sure. They're not equal, and neither are their angles. So regular, all sides will be equal, and the angles will also. So these are actually not examples of, I don't know why they're there, of regular polygons. All right. You are going to be looking at some formulas that help you find the sum of interior angles of polygons. Remember, interior means inside, so if you add up all the inside angles, those would be the interior angles. So the interior angle theorem. The interior angle theorem states that the sum of the measures of the interior angles of a polygon with n sides is, so remember n, it represents the number of sides. So make sure that you know that when you're working with your formulas, that n represents the number of sides. So that's really important so you can use the formula. And the formula is that you take the number of sides, subtract it by 2, and take that and multiply it by 180. Or you can rewrite the equation. It doesn't matter. The formula is 180 times n minus 2. So let's try it. We already know the sum of the angles in a triangle, right? But let's use the formula and see if we get that same number that we know we should be getting. So so here's our formula, 180 times n minus 2. How many sides in a triangle? 3, so we would take 3 minus 2 and multiply that by 180. 3 minus 2 is 1, so we would have 180 degrees in a triangle. Is that true? It sure is. That's what we learned all in Unit 2. So that's how we use that formula. And then you're going to learn about the exterior angles of polygons, and that's if you extend a side of a polygon, you're going to create a whole bunch of exterior angles. So you can see all these angles that you can create if you extend the lines of your polygons. So to find the angle measurement of each exterior angle, all you need to do is take 360 and divide it by n, the number of sides in that polygon. So here's an example. It says find the measurement of y. So remember, the measure of each exterior angle is going to be 306 divided by n. So it only works when you're working with regular polygons, this formula. So here we go. So we know, let's look at this measurement right here. How many sides are there in this figure? There's 4 sides. So we would take 360 divided by 4. So 360 divided by 4, we get 90 degrees. So that angle measurement of each exterior angle would be 90 degrees. All right, so I'm gonna end there, and you're gonna have, I know that was quick on the exterior angles theorem, but I did want to wrap up before this recording got too long, and you will have exposure to much more details in this week's lessons. So the week of, we're doing the week of October 27th, key phrase assignment. When using the formula, so we just talked about this formula, what does N represent? So you're going to see lots of formulas this week with N in them, and I want to make sure that you know how to use them, and tell me what does N represent when using that formula. And that's it. So I'm going to stop the recording. Have a great week, and let me know if you have questions as you're working on the assignments this week.